students, in last video we have completed the exercise we have completed the question number 2 from the exercise 4.2. Okay, now students, let us study about the new property, that is property number 6 of the definite integration. The property is that integration f of x with respect to x 0 to 2a equal to 0 to a f of x dx plus 0 to a f of 2a minus x with respect to x. To prove this property, consider RHS. Okay, so RHS of integration is that is integration 0 to a f of x with respect to x plus 0 to a f of 2a minus x with respect to x. This is the RHS. Now let us solve the RHS. Okay, and then we show that the RHS equal to LHS. So LHS is here 0 to 2a f of x with respect to x, and these are the two terms in the integration of RHS. Okay, so the first term, that is the first integration, is the simple term. But now let us solve the second term. Suppose this is the integration I1 plus integration I2. Okay, integration I1 plus I2. Okay, suppose this is 1. This is 1. Now let us consider integration I2 equal to 0 to a integration f of 2a minus x with respect to x. To simplify this property, students, let us consider 2a minus x equal to t, and now differentiate this with respect to x. Okay, so differentiation of 2a is 0, differentiation of x is minus 1, and this is dt upon dx. This implies, shift this dx to that side, we will get dx equal to minus dt. Okay, and now when we give substitution in the integration, at the time also change the limits of integration. That is, at t equal to 0, at x equal to 0, these are the values of x equal to 0, x equal to a. These are the limits of integration. So at x equal to 0, we have t equal to 2a minus x. This implies 2a minus 0. Therefore, at x equal to 0, t equal to 2a. Okay. Now, at x equal to a, upper limit is a. At x equal to a, t equal to 2a minus a. That is t equal to a. Therefore, at x equal to a, t also a. Okay, and now the limits of integration. We have the new limits of integration and our required integration I2. We are solving the I2 second integration. I2 equal to 0 to a f of 2a minus x with respect to x, and now the required integration, that is f of t, because 2a minus x equal to t, f of t, dx equal to minus dt. This is minus dt. Limits of integration at x equal to 0, t equal to 2a. At x equal to a, t equal to a. Okay, and integration I2, this is equal to plus minus f of t dt 2a to a. Now by using this property, that is by using the property integration f of x dx, that is from a to b, and this is equal to minus f of x with respect to x after changing the limits of integration by using this property. Okay, according to this property, now let us change the limits of integration, and therefore here I2 equal to a2 2a f of t with respect to t. Okay, by using this property, now again by using property number 3. Okay, by using property, that is integration f of x with respect to x from a to b equal to f of t with respect to t a to b, by changing the variable, but if the limits of integrations are same, then there is no change in value of integration. Okay, therefore by using this property, integration I2 equal to a2 2a, and this is f of x dx according to this property. Okay students, now from 1 we have RHS equal to I1 plus I2. What is your I1? I1 equal to integration 0 to a f of x dx plus, what is your I2? That is 0 to f of 2a minus x dx. And after solving this, at last we have got the value of I2, and that is equal to this. Okay, put this value in 1. We get this is equal to, that is the I2 is a2 to a f of x with respect to x. Okay students, and we know that the property of integration, definite integration, that is by integration f of x with respect to x from a to b equal to a to c f of x with respect to x plus c to b f of x with respect to x. By applying this property here, we will get RHS, that is I1 plus I2 equal to 0 to a. See students, here 0 to a and from a to 2a, and therefore this is 0 to 2a. The integrand are same, that is 0 to 2a f of x with respect to x by this property. By using this property, I1 plus I2 equal to this, and this is RHS, and this RHS equal to LHS. What is your LHS? Your LHS is that is integration 0 to 2a f of x dx, and this is 0 to 2a. Students, this is very important property which may be asked in board exam for 3 or 4 marks. Okay, so in this way very easily you can prove the property. Okay, now let us solve the example from question number 3, exercise 4.2. Okay students, the question number 3 is totally based on the properties of definite integration. Question number 1, that contain 15 marks, that is the general integration. In question number second also that contain 15 questions, and that from that 15 questions the problems were of the substitution type. And now we are solving the problems from question number 3, exercise 4.2, and these are completely related to the properties of definite integration. So let us solve the first example, that is evaluate the integration 0 to a 1 upon x plus square root of a square minus x square with respect to x. So to solve this problem, so as the square root contains square root of a square minus x square, in such type of problem the substitution is that we put x equal to either a sin t or x equal to a cos of t. Okay, so let I equal to integration of this. Suppose this is 1. Now put x equal to a sin of t. Whatever is your substitution, differentiate with respect to x. We will get differentiation of x with respect to t, that is dx by dt equal to a cos of t. Okay, and therefore here dx equal to a cos of t with respect to t. Okay, according to this. Okay, so I have given you the substitution chart. In that chart, the substitution for such type of square root, we give this substitution. Okay, and now change the limit according to the substitution. At x equal to 0, okay, that is 0 equal to a sin of t, and therefore that is 0 upon a equal to 0 and t equal to sin inverse of 0, and this implies t equal to 0. Therefore at x equal to 0, t equal to 0. Now at x equal to a, x equal to a, therefore put here the value of x. Therefore a equal to a sin of t. This implies sin of t equal to 1, and therefore t equal to sin inverse of 1, and therefore t equal to pi by 2. At x equal to a, t equal to pi by 2. Now the integration I equal to that is 0 to pi by 2. The value of dx is a cos of t with respect to t upon the value of x is a sin of t plus square root of a square minus a square sin square t. Okay students, and now this is equal to 0 to pi by 2 a cos of t with respect to t upon a sin of t plus common out a square from the square root, a square into bracket 1 minus sin square t. 1 minus sin square t is cos square t, and this is square root of a square cos square t. Okay, now square root of square get cancelled, and we will get integration I equal to this is 0 to pi by 2 a cos of t with respect to t upon a sin of t plus a cos of t with respect to t. Okay students, now common out a and cancel with the numerator. We will get integration I equal to. Now we have the integration I equal to 0 to pi by 2 cos of t with respect to t upon sin of t plus cos of t. Okay students, and the limit of integration is 0 to pi by 2. Now by using property of integration you can solve the problem easily. Which property? The property is that is integration f of x with respect to x 0 to a equal to 0 to a f of a minus x with respect to x. By using this property, here a is the upper limit. See here students. Okay, and therefore here a equal to pi by 2. Therefore integration I equal to, by using this property we can change the integration 0 to pi by 2, and f of x we can write f of a minus x, a equal to pi by 2, and this is cos of pi by 2 minus x upon sin of t is a minus t, a means pi by 2, so pi by 2 minus t is there, not x, please correct it, and cos of pi by 2 minus t with respect to t. Student, this is 1, okay, and you know that the pi by 2 minus t, cos pi by 2 minus t is sin t, okay, and this is 0 to pi by 2, cos pi by 2 minus t is sin t upon sin pi by 2 minus t is cos t plus cos pi by 2 minus t is sin t, and this is second. See student, this is integration I equal to, and now this is integration I equal to 1 and 2 must be they. This is integration I, also this is the integration I. Now add 1 plus 2, add 1 and 2, we will get 1 plus 2, and if LHS I plus I, that is 2i equal to 0 to pi by 2, that is cos of t with respect to t upon sin of t plus cos of t plus 0 to pi by 2 sin of t upon cos of t plus sin of t, and the addition is 0 to pi by 2, add this plus this with respect to t, that is cos of t plus sin of t upon sin of t plus cos of t and with respect to t, and the denominator numerator get cancelled, and 2i equal to 0 to pi by 2 1 with respect to t, and its integration of 1 with respect to t is t, and the limits of integration 0 to pi by 2, and this is equal to pi by 2 minus 0, hence the integration I equal to, that is 2i equal to pi by 2, and therefore integration I equal to pi by 4. Shift this 2 to that side, and this is integration of 1 upon x plus square root of a square minus x square with respect to x, limits of integration 0 to a. By using property we have solved the problem, and this is the solution. Okay, now let us solve another example. Another example is that evaluate the integration, that is integration of log of tan of x with respect to x, and limit of integration, that is 0 to pi by 2. Students, let us consider the integration I equal to log of tan of x with respect to x. Okay. Now, to solve this integration, again by using property. Okay. By using property, this is integration I. Suppose this is equal to 1. Okay. By using property, that is 0 to a f of x with respect to x equal to 0 to a f of a minus x with respect to x. By using this property, let the integration I equal to 0 to pi by 2. Here a, by using this property, this is log of tan of, we can write a minus x means a is pi by 2, this pi by 2, therefore this is pi by 2 minus x with respect to x. Hence integration I equal to 0 to pi by 2 log of tan of pi by 2 minus x is cot x. Tan of pi by 2 minus cos x is cot x, and this is log of cot of x with respect to x. This is second. Now add 1 and 2, we will get, add 1 plus 2, add 1 and 2, that is integration, add 1 and 2, we will get I plus I, that is 2I, equal to integration 0 to pi by 2 log of tan x, log of tan of x with respect to x, plus 0 to pi by 2 log of cot of x with respect to x. Okay. And this is equal to integration 0 to pi by 2 log of tan x plus log of cot x whole with respect to x. Okay, and this is 2i equal to integration 0 to pi by 2 by using rules of logarithm, that is log of m plus log of m is log of m into n. This is log of m means tan of x into cot of x. And students, you know tan x and cot x are reciprocal of each other, and therefore their calculation is 1, and this is 0 to pi by 2 log of 1. 2i equal to log of 1. You know that the value of log 1 is 0. 0 to pi by 2 with respect to x, and integration of 0 is 0. Okay, and therefore this is the integration of 0 to pi by 2 log of tan of x with respect to x. Now let us solve another example, that is evaluate the integration of evaluate the integration 0 to 1 log of 1 upon x minus 1 with respect to x. Okay, again by using, let suppose integration I equal to this, suppose this is 1. Now by using the property, that is integration 0 to a f of x with respect to x, and this is equal to 0 to a f of a minus x with respect to x. Okay, so let apply the property here and we will get integration I equal to 0 to 1 log of this log of 1 upon x minus 1. First we simplify this. Okay, and this will be log of 1 minus x upon x, log of 1 minus x upon x. Okay, with respect to x. Again by using the rules of logarithm, by using the rules okay, suppose this is the simplification of this property, that is 1 upon x upon x. Now suppose this is 1, simplification of this is same as this. Now applying this property, integration 0 to a f of x with respect to x is 0 to a f of a minus x. By using this property, this is integration I equal to 0 to 1 log of. Okay, by using the property, that is this 1 will be as it is, this x will be 1 minus x. Okay, this x will be 1 minus x, and again this x is 1 minus x because a minus x, a is 1 here. Okay, in this way this is the second by using this property. Okay, and this is equal to 0 to 1 log of 1 minus 1 get cancelled, and that is minus minus plus x upon 1 minus x with respect to x. This is the second. Now add 1 and 2, we will get, add 1 and 2, we will get integration I equal to I plus I, that is 2i, 1 plus 2. What is your 1? That is 0 to 1 log of 1 minus x upon x with respect to x, plus what is your second? That is 0 to 1 log of x upon 1 minus x with respect to x. So after adding 1 and 2, we will get integration 2i equal to 0 to 1 log of. Okay, by using rules of logarithm, that is log of m plus log of n, and that is equal to log of m into n. Okay, and that's why it is log of 1 minus x upon x into x upon 1 minus x by using this property for adding this. Okay, so get cancel, and this is equal to integration 0 to 1 log of 1 with respect to x. Okay, and students, you know that log of 1 is 0, integration 0 to 1 log of 1 is 0 with respect to x is 0, and integration of 0 is 0, and this is the integration of 0 to 1 log of 1 upon x minus 1 with respect to x equal to 0. Okay, now students, let us solve one example as a homework. The homework problem is that, this is the homework problem for you. The homework problem is that evaluate integration 0 to pi by 2, 0 to pi by 2, sin of x minus cos of x upon 1 plus sin x into cos x with respect to x. Okay students, so again by using the same property, that is integration, the same property, integration f of x with respect to x 0 to a equal to integration f of a minus x 0 to a with respect to x. By using same property, okay, then you will get the second integration I. Then after adding first and second integration, you can solve the problem very easily, just like as just we have solved the 2 or 3 problems. According to that, you have solved the same problem. Okay, in this way solve and send it to me on my WhatsApp. Remaining problem we will continue the next video.